Hi, and good morning, good afternoon, good evening, wherever you're dialing in from. Welcome. I'm happy to be here today with my fantastic co-host, Dr. Friedrich Jacobi, CFO at iSquare. My name is Krzysztof Radecki. I'm CTO at DAC.digital. We're here to share the story behind Seal, a tool we developed together at DAC.digital and iSquare. Seal uses AI to give real time, in context insights into how people behave as consumers. It's a big step forward in how brands can understand and connect with their audience. We started the project with clear planning and goal setting, working closely with the iSquare team to make sure we were aligned on the core priorities: scalability, accuracy, and making sure Seal would be useful in real world, in context situations. Next was building the technical proof of concept. That stage was all about testing the core idea behind Seal to make sure it was technically possible before moving to full development. Then came data. We needed a lot of it, and it had to be high quality and diverse. So we put together a custom data collection process to make sure that what we are training the model on actually reflects real life usage. Once we had the data, we focused on training and testing the AI models, making sure it could perform well across different devices and environments, while staying accurate in tracking where users were paying attention. And finally, deployment. We designed Seal to be browser-based and hardware-free, so it's easy to roll out at scale, whether you're on mobile or desktop or tablet. Building Seal definitely came with a challenge. Every part of in-context tracking had its own technical headaches, and we had to come up with smart ways to handle them. But honestly, that's just how it goes in AI projects. First, again, the data. We needed big, diverse data set, but what was already out there wasn't good enough from our perspective, especially for commercial use. Then there was the issue of different devices. Since Seal has to work on all kinds of phones, we built auto calibration so it would stay accurate no matter what device you or the customer is using. Real-time performance was another big one. Making it run smoothly on fast-changing environments meant we had to build a super efficient and flexible system. And finally, full end-to-end calibration was key. Without it, we wouldn't be able to turn gaze data into something actually useful in real-world scenarios, real-world settings. One of the biggest challenges we faced early on was the lack of proper training data that I've already mentioned, I guess. To make Seal accurate in real-world use, we needed a very diverse data set, different devices, lighting conditions, backgrounds, and user demographics. Some of us have lighter skin, some of us have darker skin. Same goes with eye and the shape of the face. Existing data sets just didn't cut it. They were either too limited or didn't have the variety we needed to train the model that could handle real use across many devices. On top of that, public data sets often come with licensing restrictions, so we couldn't rely on them for commercial use. That's why we had to build our own from scratch with real users and real world conditions. This, I guess, is a common roadblock in AI work, but it was especially key for Seal to get things right. To get the right data, we built our own custom system. We made a web application to collect data, then brought in users from different places using crowdsourcing. Then we made sure to cover a wide range of devices, lighting conditions again, and user types. And to keep quality high, we checked and cleaned all the data before using it in tracking. Now, here's the final data collection tool. It's a very simple web application, nothing flashy, nothing fancy design-wise, but it does its job and it does its job well, basically exactly what it's needed. You can see the application prompt on the left-hand side, the user using the application right now. Then the red dot is pointing or showing on the screen, and the user is supposed to track the dot with his eyes, with his gaze. And finally, all the data, including metadata and recorded video, is sent to our backend for processing. Now, here's a quick look at the scale of our data collection. We had over 3,100 users and gathered data from more than 1,800 different device types. which gave us a lot of variety in screen sizes, cameras, and obviously the setup. And to make sure the quality was there, we filtered out the low quality samples, things like blurry images, wrong angles, and poor lighting, using both manual checks and semi-automated tools. The photos below you can see are great examples of what not to include the training data sets. And finally, this slide shows the effect of our calibration process. Pay attention to the left-hand side initially. The crosses, they're kind of faint, but you can see them, are the target points shown to users on screen at various random timestamps. The red dots, or the dots, are where the model thought the user was looking before calibration. The colors match. For example, red dots come from the moment a red cross was displayed, blue dots from the moment when the blue cross was displayed, and so on and so forth. On the left-hand side, you can see two clear problems. First, the dots are shifted. They don't line up well with the crosses. Second, there's a lot of spread within each group, meaning that the model was not consistent. On the right-hand side, after calibration, we fixed both issues. The dots are now much closer to the correct targets, and the spread within each group is much, much tighter. This is where we show how accurate SEAL really is. This is where we show how accurate SEAL really is. On the right, you can see a live eye tracking example. The red cross shows where SEAL thinks you're looking, and the blue cross is the actual target. As you can see, it's pretty much close. SEAL tracks gaze with high precision, usually within 1.5 centimeters of the real point, and it works across different devices, screen sizes, and camera setups. It also performs really well in real-world conditions, whether it's bright daylight, low light, busy backgrounds, or small head movements. It works really perfectly from our perspective. We also ran tests against standard in the industry, and SEAL delivered strong results, quick feedback, a low delay, and very solid accuracy. So what's the outcome of all this? We get instant feedback on where user is looking in real time. It works like this. SEAL captures gaze and head pose data right away, processes it instantly, and turns it into clear insights about user engagement, all with very, very low delay. And for brands, that means three big things. You can track attention as it happens. You can adjust content or layout based on what users actually do. And you can improve the overall experience on the fly while users are still interacting. Now, looking ahead, there are some exciting areas where this technology could go next. In healthcare, for example, gaze tracking can support things like patient monitoring or cognitive testing, helping doctors spot early signs of issues or diseases. In education and training, it could be used to measure student or employee focus and adjust the learning process based on real engagement. And in retail, both online and in stores, it could help understand what actually grabs the attention of the consumer, so brands can improve product placements and layout. And if you look beyond SEAL, DAC.digital's AI and computer vision skills open the door to even more use cases. In manufacturing, we're helping spot defects and improve quality control. In agri-tech, we use drone footage and field cameras to monitor crop health. For logistics, it's about tracking and automating workflows using visual systems. Healthcare, again, we apply similar techniques as in SEAL for patient monitoring. And in retail, we support physical store analysis, helping brands understand how shoppers move and interact with the products. And now allow me to hand over to my friend Friedrich, who will conduct the second part of the presentation from I2's context. Friedrich, the floor is yours.
Thank you, Krzysztof, very much for showing the SEAL development and also the SEAL architecture. We are very grateful to having found with DAC such a competent partner to jointly develop this very ambitious project. And I'm now going to show you what are we using SEAL for and what are the SEAL applications from a market research point of view. So SEAL, our smart eye tracking algorithm, It's our premium solution mainly for smartphone eye tracking, but also for other devices. And the main thing is that it works in the browser, no app download is required. How is it working? If you see how information is processed, you have 3 different levels. You have the system 0 level, the attention level. This is where SEAL comes into play. Then, of course, we have the feeling and the thinking, the system 1 and system 2. So with SEAL, we have a great tool to track attention on the system 0 level, and it determines actually where a user is putting the attention to on the webcam or on the smartphone. So what are the benefits of our technology? It's an AI-based technology. We have already patented algorithms for calibration and other things. It works regardless of the platform. It works on smartphones, on tablets, on laptops. No browser is needed. It's scalable, fully scalable, and the benefit also is that it allows realistic test environments that are natural to the user. So no need to come into a testing studio anymore. The user can do the tests from the couch, from the sofa at home. And of course, we have automated results coming along with the technology. We mainly use eye tracking, the SEAL eye tracking, to support our in-context technology in the social media, but also on the e-com side. With social media, we can support most of the common social media platforms like TikTok, Instagram, Facebook, YouTube, Snapchat. And with this add-on, we can not only determine what the user is doing while scrolling through these social media platforms, but also where the user is looking at with the SEAL technology. And this allows us to truly understand if an ad that is shown on the social media feed or something else is relevant to the user, because we can track if the user is paying attention to it and is looking to it. So how does it work from a testing point of view? Well, our SEAL in-context technology works together with online panels. So we recruit the test participants via online panel. Then the panelists are routed to our testing platform, where we do the exploration, we do the eye tracking, and then typically at the end, it's followed by a small survey that is based on the client needs. And throughout this process, we have SEAL supporting this, where initially we do the capturing after the calibration. Then, of course, we do the analysis, and then finally we generate automatically the eye tracking results. So how does it work from a practical point of view? We have an instruction phase, then we have a calibration phase, and then we do the actual in-context testing. So from an instruction phase, of course, the user has to apply or give consent from a GDPR point of view. Then we have the calibration phase, where the system is calibrated to the user, as Krzysztof described previously in his presentation, and then we do the actual testing. So this gives a good understanding of the participant flow, and as I mentioned before, the test participant is fully aware of the use of eye tracking. In fact, he or she has to consent to it prior to doing the test. So what type of insights do you get afterwards? Well, initially we have, of course, the in-context test results that we track automatically from scrolling through the social media feed, like if an ad was visible, if someone has clicked on the ad, if, for example, sound was active or not. And these metrics are automatically recorded. And in addition, you get the seal metrics. And these are in particular, so how long has someone looked at the ad? This is the dwell time. Or how long did it take for someone until the person looked at the ad initially? And how many persons looked at the ad at all? So this is by analyzing the areas of interest, we can go very deep and give precise data if an ad is recognized or not. And as it's based on where the user is actually looking at, we can even define this and make it more granular than just one big ad. We could, for example, define multiple areas of interest, and then we can determine 4 or 6 or 7, 8 areas of interest and address these individually if they were addressed by the user or not. So how can this apply to in practice? Here you see an ad from Carnival Cruises that was a popular ad on TV and especially also on YouTube. And it's a small 15-second ad, but you can clearly see where the attention of the users is picking up based on the scenery and the playbook of the ad. And for example, at second 3, attention arises. So this is something and similar again in second 8. And this would be a good opportunity, for example, to use for branding, as the users is paying high attention. 45% of the users looked at this ad at this moment in time. So by injecting a logo or something would help, for example, to make this ad more attractive and meaningful to the user. And on the other side, on the at the end of the ad, we see that the attention is going down a little bit. So you may want to think about ways to increase the attention or keeping up the attention. And this is a perfect tool that we can offer to brands to analyze their digital content. So this was a small use case also from our perspective, from a market research perspective. As Krzysztof already mentioned, there are many more applications, not only in market research, but also beyond, where the seal technology could be applied for and used for. And we are looking forward to explore this further and having more projects together with the DAC.digital. So thank you very much also from my perspective.
And thank you, Friedrich, for your amazing presentation. Thanks to all of you guys for participating today. I hope to see you soon in our next presentation. And until then, have a great and fantastic day. Bye, guys.